All right, welcome back to online learning. This is a little bit different because you are watching lesson videos rather than me standing in front of you, but hopefully it will not be any more confusing. When you left for spring break, we had just finished up chapter 8, which was all about similar figures, similar triangles specifically. So we are moving on to chapter 9, which is our trigonometry chapter. The bulk of this, not the bulk, but a lot of this work is done on the calculator. Some of it you can't use a calculator for because it can't simplify it the way you need it to. However, a lot of it will be done in the calculator. So we're starting off hopefully nice and easy for you, going back to Pythagorean theorem, which is just our normal a squared plus b squared equals c squared. Okay, so Pythagorean theorem, always for a right triangle. You can't use Pythagorean theorem for anything other than a right triangle, so always make sure that if you're solving for a side that you know that it is one. So Pythagorean theorem, a squared plus b squared equals c squared. Your book tends to rewrite it and puts the c squared first, but that literally does not matter. The only thing that you have to remember is that it's your legs squared and added together equal to your hypotenuse squared. So your hypotenuse, remember, is always across from the right angle. And your two legs are always connected to the right angle. We also have what are called Pythagorean triples. You won't have to memorize these necessarily. You will use a lot of them very frequently, but you don't have to memorize them. Now, these top ones that I'm highlighting right now, those are the basic triples. So everything else is just a multiple of that. So for the 3, 4, 5 triangle, 6, 8, 10, 9, 12, 15, 3x, 4x, 5x, those are just multiples of it. So to get from 3, 4, 5 to 6, 8, 10, we multiply by 2. To get from 3, 4, 5 to 9, 12, 15, we multiply by 3. And it's the same for all of the other triples as well. But 3, 4, 5, 5, 12, 13, 8, 5, 17, 7, 24, 25. Those are your common Pythagorean triples. The two smaller numbers are always legs on your triangle. The larger number is always your hypotenuse. The hypotenuse always has to be the biggest side of your triangle. Always. Okay, so we are going to jump right in to solving for a missing side. So we're just finding whatever value is missing with Pythagorean theorem, and then we're just going to determine, does it form a Pythagorean triple? So Pythagorean triples, remember, are whole numbers. So there's no decimal, no fraction, or anything like that. So in order for it to be a Pythagorean triple, every number has to be a whole number. Every side length has to be a whole number. So when we have in number 1, side lengths of 4, 6, and x, we're going to solve for x, which is across from the right angle, so it is a hypotenuse. So remember, it's a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. So 4 is a leg, 6 is a leg. So we're just plugging into that formula. 4 squared plus 6 squared equals x squared. It doesn't matter if you do 4 squared plus 6 squared or 6 squared plus 4 squared. You're going to get the same answer either way. So we square both of those. 16 plus 36 equals x squared. 16 plus 36 is 52. Now remember, when we have an x squared and we need to solve for x, we are going to square root that. So we're going to square root both sides, which is not a perfect square. We end up with about 7.21 for x. So not a whole number, which means that it's not a Pythagorean triple. Okay, so what I would encourage you to do is to kind of go back through each of these problems as we do them. Replay it if you're not sure what I did or if you missed something that I said before you keep going. Okay, so we're going to do the same thing in number 2. X, the side that we need to find, is connected to that right angle. So this is a leg. 3 is a leg. 5 is opposite of our right angle. So that's our hypotenuse. So x squared plus 3 squared equals 5 squared. 3 squared is 9. 5 squared is 25. I'm going to subtract my 9 on both sides, which is going to give me x squared equals 16. And then again, to get rid of our squared, we square root both sides. Square root of 16 is 4. So we have a whole number here. So every side is a whole number, which means that is a Pythagorean triple. All right, in number 3, we have an anemometer, a device used to measure wind speed. The anemometer shown is attached to the top of a pole. Support wires are attached to the pole 5 feet above the ground. Each support wire is 6 feet long. How far from the base of the pole is each wire attached to the ground? So I don't want you to stress about this because it's the same thing that we did before, and it's just in a story problem form. So here's what we're using to measure wind speed here. It's 5 feet off the ground, so that 5 feet is just this side right here. And then there is support wires that go to the top to the ground. So this is just our support wire. It's 6 feet long. We want to find out how far from the base of the pole it is. So we're just looking for this bottom piece right here. Okay, so nothing changes in what we're doing. We're still doing Pythagorean theorem. So 6 is our hypotenuse. 5 is a leg. D is a leg. So 5 squared plus d squared is going to equal 6 squared. 5 squared is 25. 6 squared is 36. I'm going to subtract my 25 on both sides to get 11. And then I'm going to take the square root on both sides so that d is by itself. And we end up with the square root of 11, which is about 3.3 feet. Now remember, you're asked for how far away something is. You're asked for a distance. So you want to make sure that you add on whatever your units are, in this case, feet. All right, our other theorem, the converse of the Pythagorean theorem, just says that if the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then it's a right triangle. So you might not know if your triangle is a right triangle, and they're asking you if it is. Well, you can plug it into Pythagorean theorem, and if it's true, if it works, if you get the same thing on both sides of the equal sign, it's a right triangle. If you don't, it's not a right triangle. So for example, if we, I'm going to just use one of those Pythagorean triples because we already know those are right triangles to show you what I mean. So 3 squared plus 4 squared, is that equal to 5 squared? Okay, so remember your biggest side has to be the hypotenuse, so 5 is our biggest side, so we're plugging that in for C. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. So we've got 25 is equal to 25, which makes that a true statement, and side lengths of 3, 4, and 5 a right triangle. Okay, so in 4 and 5, that's what we're doing. We're going to figure out, do these form right triangles or not? So your biggest side has to be your hypotenuse. If you're not sure, which one your longest side is, like if we look at number 4, 3 times the square root of 34, that's hard to determine if that's bigger than the other two sides. So check it in your calculator. When you do 3 times the square root of 34, you end up with about 17.5. So that is going to be our hypotenuse, or what we're assuming is our hypotenuse. It's going to be our C value, and then that makes 9 and 15 A and B. And again, if you do 9 as B and 15 as A, that doesn't matter, as long as it's the two sides added together. So 9 squared plus 15 squared, is that equal to 3 times the square root of 34 squared? So 9 squared is 81. 15 squared is 225. Now, when we're squaring 3 times the square root of 34, we're squaring the 3, we're squaring the square root 34, and we're multiplying them together. You can plug that into your calculator all at once, but you have to make sure you put the 3 square root 34 in parentheses. If you don't, it's only going to square the 34. So when we square that, we end up with 306. And when we add our 81 plus our 225, we get 306. That is equal to 306. So it does form a right triangle. I would encourage you to pause the video now and try number 5 on your own. We're doing the same thing. Your two smaller sides are A and B. Your bigger side is going to be C, and you're just determining, is that going to be equal to each other? Are both sides of the equal side going to be the same value? All right, so 14 squared plus 22 squared, is that equal to 26 squared? Well, I'm just going to work it out piece by piece. 14 squared is 196. 22 squared is 484. And 26 squared is 676. So I add my 196 and my 484, and I end up with 680, which is not equal to 676. So this is not a right triangle. Okay, our last theorem for this first section is the Pythagorean inequalities theorem. This can be a little bit tricky at first. I would encourage you to really focus on what the inequalities are saying and try to remember it that way. But basically, if you plug into Pythagorean theorem and it doesn't work, then depending on what the numbers are, you would have enough information to say, oh, well, it's not a right triangle, but it's an acute triangle. Or it's not a right triangle, but it's an obtuse triangle. So when Pythagorean theorem does not work and your hypotenuse is smaller than your two legs added together, or what would be your hypotenuse, your C value is smaller than your two legs added together, then it's going to be an acute triangle. If your C squared value is larger than your two legs squared and added together, then it's going to be an obtuse triangle. Okay, so you're just plugging that in. If C squared is smaller than A squared plus B squared, it's acute. If C squared is bigger than A squared plus B squared, it's obtuse. So in number 6, verify segments with lengths of 3, 4, and 6 form a triangle. So we did that a while ago. Remember, any two sides just have to add to be bigger than the third side. If those are all true, it forms a triangle. So 3 plus 4 is 7, which is bigger than 6. 4 plus 6 is 10, which is bigger than 3. 3 plus 6 is 9, which is bigger than 4. So it does form a triangle. Now we just have to figure out, is it an acute triangle, a right triangle, or an obtuse triangle? So your bigger side has to be your C value. So that's going to be 6. 3 and 4 are going to be A and B. So 3 squared plus 4 squared. And then we got to figure out how it compares to 6 squared. So 3 squared is 9. 4 squared is 16. 6 squared is 36. So I add my 9 and my 16. I get 25. That is less than 36. So C squared is greater than A squared plus B squared. Because remember, this is my C value. That was my C squared value. So when C squared is bigger than A squared plus B squared, we have an obtuse triangle. Okay, so we're going to do the same thing in number 7. I want you guys to pause the video, try this one on your own, do the same thing. Verify it forms a triangle, then plug it into your Pythagorean theorem, figure out, is it an acute triangle, a right triangle, or an obtuse triangle? Okay, so when we're verifying, 2.1 plus 2.8 is bigger than 3.5. 2.1 plus 3.5 is bigger than 2.8. And 2.8 plus 3.5 is bigger than 2.1. So it does form a triangle. So 2.1 and 2.8 are my A and my B values. 3.5 is going to be my C value. So I'm just going to square each of those. So 2.1 squared is 4.41. 2.8 squared is 7.84. And 3.5 squared is 12.25. So 4.1 plus 7.84, 4.41 plus 7.84 is 12.25, which is equal to our C squared, 12.25, which means that these three sides form a right triangle. Okay, so that is all there is to section 1. You will have a assignment posted on Big Ideas Math, just like we've always been using. Feel free to go back and look through these notes as you need. If you have questions, email me, request a Google Meet or a Google Hangout, whichever is easier, and let me know if you have any questions.